In this lecture, I'm going to introduce a new notion of a subsequence. To give you an example of what this is, let's consider the sequence Sn. So consider a sequence Sn may be equal to 1 over n. So if I write the sequence out, then this will give me S1 equal to 1, S2 equal to 1/2, S3 is 1/3, S4 1/4, and so on. We can also consider the following sequences. So we can also consider, let's call this sequence Tn. Tn is going to be 1 over 2n. And if I write this sequence out, I'm going to get 1/2, 1/4, 1/8, 1/16, and so on. And in addition, we can also consider a sequence. Let's call this one Pn, and this maybe is 1 over 3n plus 1. Again, if we list that sequence now, when n is equal to 1, you're going to get 1/4. For n equal to 2, it would be 1/7. N equal to 3, 1/10, and maybe one more. For n equal to 4, 1/13, and again, and so on. Is there anything between these sequences that is going to be in common? Are any terms of these sequences common between them? If I look at Sn, right, Sn is 1 over any integer. So then Tn is 1 over any even integer. But 1 over even integer is going to be also included here, right? 1 over any sequence of 1 divided by any integer will include in itself a sequence of 1 divided by any even integer. So all terms of Tn are actually going to be in Sn, also terms of Sn, and they appear in Sn in the same order, right? So all elements of Tn are also elements of Tn, of Sn, and they're in Sn in the same order. So appear in Sn in the same order. And if we look at Pn, we see that actually a very similar thing is going to happen here. Pn is 1 over any integer of the form 3n plus 1, so starting from 4, I'm including any integer like that, right? So 1/4 and 1/7, 1/10. So each time I add 3 to my denominator, and clearly in this case, exactly the same thing will happen as in the case of Pn, because all terms in Pn, like 1/4 also appears in Sn, 1/7, even though I didn't list it in Sn, right? We know 1/4, 1/5, 1/6, and then 1/7. It also appears in Sn. Same thing for 1/10, 1/13. So all elements of Pn are also elements of Sn, and again, they appear in Pn in the same order as they do in Sn. So we can just copy this statement and include it here. Okay, so in a sense, then, Sn is a sequence that is larger than Tn because it contains all elements of Tn in the same order. So that means that Sn is a larger sequence. It has more elements. The same relationship between Pn and Sn. Every element of Pn is also an element of Sn, and order of these elements is exactly the same in both Pn and Sn. So we then say that Pn and Tn, well, actually, yeah, let's write it like that for now. So Pn and Tn, we will say, are subsequences of Sn. And clearly I can produce infinitely many subsequences like this, right? Because I can take a subsequence 1/4n plus 1, or a sequence of 1/16n. There is an infinite number of recipes by using which I can extract only certain elements of my original sequence Sn, right? So for example, if I have a sequence like 1, 1/3, 1/50,000, 1/1,000,000, 1/1,006,000, and I just keep going in this order of increasing denominator by just picking out particular elements, terms of Sn. At the end of the day, I'm going to end up with an infinite sequence, and that sequence is going to be contained inside my original sequence. So it must be a subsequence. So now I'm going to try to make this a bit more precise. And I'm going to do that in the following way. So obviously, n in Pn and n in Sn has a somewhat different meaning. What do I mean by this? In Sn, the first element is 1, the second element is 1/2. If I look at Tn, the way I define Tn, the first element of Tn is 1/2. But that first element actually is a second element in my original sequence. My second element in Tn is a fourth element in the original sequence. So I want to be able to somehow express, I want to relate actually, the indices that appear in Tn and indices that appear in Sn, again, because the position, let's say, of 1/2 in Tn and Sn is not the same. Index is not the same. Index of 1/4 and 1/4 here, they're not the same. So I have to come up with some way of converting between indices of both of these sequences. And the way I'm going to do that, so again, I'm going to continue the same example. So to relate indices of Sn and Tn, for example, we can do the same thing with Pn later on. Let's do this. First, I'm going to relabel Tn. Instead of calling it Tn, I'm going to call it Tk. So k is going to be still greater or equal than 1. And the formula for Tk then is going to be is 1 over 2k. Right. Okay. In fact, Tk equal to 1 over 2k, I can also write as follows. We discussed that before. T, in a sense, is a function, when I'm writing Tk, T is a function of its index. So rather than writing Tk is equal to 1 over 2k, I can equivalently write that T of k is 1 over 2k. All right. So now let's look at Sn. So for Sn, I know that Sn is equal to 1 over n. And I can write this in equivalent way as S of n equal to 1 over n. All right. And so then what have I got? I got that to get Tk, would I be able to get Tk from Sn, from S of n? Well, I can do it like this. I can say that Tk, which is 1 over 2k, what is that? That's the same thing as 1 over n, with n being equal to 2k. So this is the same thing as S of 2k. And what is S of 2k? That is S with an index 2k. So basically, the way to associate elements of Tk to the original sequence Sn is to provide the relationship between n and k. So just thinking about this, so if k goes from 1 to infinity by all integers, right? So k is equal to 1, n is equal to 2, k is equal to 2, n is equal to 4, k is equal to 3, n is equal to 6. In fact, that's what I'm missing here. I seem to be missing 1 6, sorry for that. So in that way, by looking at S2k, I'm going to go through all possible elements of Tn. So, and we can do the same thing for my second example. How can I see that Sn and Pn are related? So let's do the same surgery here. So to relate elements of Sn and Pn, and Pn, what do I need to do? I relabel Pn. I use a different index k, so that pk is going to be 1 over pk plus 1. And Sn is still, this gives me, again, a function p of k is equal to 1 over pk plus 1. And then Sn is still, of course, equal to 1 over n. So if I think about Sn as a discrete function, S of n equal to 1 over n, then let's get rid of this. Then what is my pk? pk is 1 over 3k plus 1. 1 over an integer, I call that s. So if I make n equal to 3k plus 1, this will be s of 3k plus 1. And also I can write this as s 3k plus 1. So once again, what does it mean to have s 3k plus 1? It means that as I run k from 1 to infinity, what kind of terms will I encounter? I will need to take s 3 times 1 plus 1 as 4. Then the next s that I will need to select would be s of 3 times 2 plus 1 as 7, then s 3 times 3 plus 1 as 10. That's exactly the elements that I'm seeing here. Right, so my subsequence tk essentially would be a subsequence of a regional S, where I only choose even indices. And the second subsequence pk actually is going to be a part of a sequence where I only pick the elements with indices that are equal to 3k plus 1. So generally now, let's try to give a definition of a subsequence. So definition. Given a sequence Sn and the function and an integer, in fact, a positive integer valued function let me add one more thing here, not just a positive integer value function, but there is more. One more thing that I have to mention here. Positive and strictly increasing integer valued function n of k. a subsequence. S and K is defined as S and K is equal to S of N of K. So what we're doing is we're taking this strictly increasing integer value function, and it's a function that is not only integer valued, but it's also defined on integers. That function tells us which indices of the original sequence we would like to consider, and out of these indices we then construct a new sequence. Let's try to, so basically this is exactly the same thing as what I did in the examples above, right? So in this case I had a function n of k equal to 3k plus 1. Now clearly 3k plus 1 is an increasing function which has integers as input and integers, positive integers as input, positive integers as an output. Same thing here. This function n equal to 2k has positive integers as an input, and it has positive integers as output. And both of these functions are, both this one and this one, are, of course, strictly increasing. Why do I want this function to be strictly increasing? Because I want to extract elements from my sequence in the same order as they were in the sequence originally, right? So then if I, for example, look at n of 1 and n of 2, right, n of 1 must be strictly less than n of 2. So that means that I can never choose as a next element. So first element of my sequence is going to be an element with an index n of 1. And then the next element is going to have an index n of 2, and n of 2 is larger than n of 1, so it means that the second element that I'm going to choose is going to be located, positioned to the right of the original element, of the element n1 in my sequence. Likewise, n of 3 is going to be bigger than n of 2, so that means that the third element in my subsequence will be chosen from somewhere to the left, to the right of the index n of 2. And you're going to continue in the same way forever, because n of k is a function which is strictly increasing. So let's get rid of this. More examples. Let's say I have a sequence Sn equal to minus 1 to the power n. Right, so then Sn will have this form, minus 1 to the power 1, that's minus 1, then minus 1 squared 1, then minus 1 to the what power, minus 1 cubed minus 1. And just like as we discussed before, a sequence like that will simply consist of alternating 1s and minus 1s. Okay, so without looking at the definition that I just gave, let's think about possible examples of subsequences here. Well, so if my original sequence is minus 1, 1, minus 1, 1, minus 1, I can in principle go ahead and pick the elements just like I did before, every even element. So then S, how do I pick an even element? not even elements, elements with the even index. What are those elements? Are S to k, right? Because then if k goes from 1 to infinity, then 2k will go from 2 to infinity, going through all integers. So what is S to k? That is going to be minus 1 to the 2k, and minus 1 to an even power is always 1. So that means that S to k will look like 1, 1, 1, 1, and so on. It will be just a sequence of ones, which is obvious actually from here, right? Because if I choose every even element, I'm just going to see 1, then next one, then 1, and so on. So this is a subsequence. Of Sn. Well, let's think of another example. So another example can be maybe, in fact, I'm not sure that we need implications here. Actually, let's just label these things by stars. How about S2k plus 1? S2k plus 1 will look like minus 1 to the 2k plus 1. Minus 1 to the odd power is minus 1, so this is still minus 1. And this should be true for every odd term. So then I'll see a sequence minus 1, minus 1, minus 1, minus 1, and so on. And this is also a subsequence of Sn. Now, I specified all of these subsequences by giving, again, this function n of k, right, which relates indices in a subsequence to the indices of a regional sequence. Well, I can maybe do something like this also. Maybe S 4k. What is S 4k? This is minus 1 to the 4k, and that again is minus 1 to an even power. So once again, it is equal to 1. And because it's equal to 1 for every element of a subsequence, and again, the subsequence is going to be 1, 1, 1, 1, and so on. So clearly this is still a subsequence, right? But is it the same subsequence, for example, as S2k? It looks the same, but it's not the same, because what am I doing now? I'm not choosing every second element of a sequence when I'm doing S4k. I'm choosing every fourth element. And it just turns out that that subsequence will have exactly the same form as a regional sequence, but yet they are chosen in a different way, right? So it's this one, then the next fourth element is 1, next one is eighth element of my regional sequence is 1, and so on. So sequences look the same, but they correspond to different subsequences of that regional sequence. I can also, so if just one more observation here, if somebody gives you a sequence that consists just of ones and asks you what what subsequence of a regional sequence that is, you can see now that you cannot really say, because every sequence of every even elements is only ones. A sequence of every elements with an index 4k is only 1. It will consist of ones. S8k will consist of ones. So there are infinitely many possible subsequences of minus 1 to the n that will consist only of ones. Likewise, if I have a sequence that looks like this, minus 1 maybe minus 1, 1, 1, minus 1, minus 1, 1, 1, and so on. Is that a subsequence of the original sequence? Well, yes, right? Because how can I produce this sequence of minus 1 and 1s? For instance, I can take the first element, it's minus 1. I can take the third element, it's minus 1. Then I take a fourth element, it's 1. Then I take a next element, which is 1. That would be 1, 2, 3, 4, 5, 6 element is 1. Then seventh element is minus 1. Ninth is minus 1. And so on. So this sequence of minus 1s and 1s is another particular example of a subsequence of Sn. And similar to the previous comment that I made, this subsequence actually correspond to many different possible ways of extracting a subsequence from minus 1 to the power n, right? Because my first two elements have to be minus 1s. So I can take, for instance, first and then third, and that will give me two minus 1s. I can take first and fifth, and that again will give me two minus 1s. So the only rule that you have to follow in this case is that as you proceed along your subsequence, you have to pick elements that are further to the right than the previous element that you picked. You have to move along the sequence in the same direction as you move along the subsequence. And that is again related to the statement that I made before, that I want to have integer valued function n of k, which is positive and strictly increasing, right? That means that ensures that we always move along the sequence, along this given sequence, to the right, towards the tail. Maybe one more example. Actually, before one more example, based on what we just did here, and in the previous examples, it's obvious that any given sequence will then contain infinitely many subsequences, right? Because there are infinitely many ways for me to pick elements of the sequence on which I want to consider, right? So as long as I keep going to the right, while I'm picking the elements, that will give me a legitimate subsequence. And that also is manifested in the way that if I have an integer valued function, positive integer valued strictly increasing function, n of k, there are infinitely many functions like that. And to each n of k corresponds a specific subsequence Snk. So one more example. Let's say I have a sequence Sn equal to 1 over 2 to the power n. And I have a question like this. Number 1 is 1/2, 1/4, 1/8, actually 1/16, 1/8, 1/32, etc. Is this a subsequence of Sn? Well, how do I decide? How does my n of k, in this case, how is it going to look like? So 1/2 then is going to be, let me rewrite this. So this will correspond to n equal to 1, right, in my original sequence. This corresponds to n equal to 2. This corresponds to n equal to 4, right, because 16 is 2 to the 4th. This corresponds to n equal to 3. Then n equal to, I don't know why is it, yeah, n equal to 5, etc. Maybe let's do one more. 1/64 here. So this is n equal to 6. So how does my n of k look like? Right, n of 1 is 1. N of 2, right, in the second position, is 2. Then n of 3 is equal to 4. N of 4 is equal to 3. N of 5 is equal to 5. And n of 6 is again equal to 6. Right, those are the indices that appear in my presumed subsequence. So is this a subsequence or not? And I claim that the answer is no. And the only reason why this is not a subsequence is because when I go from n of 3 to n of 4, my function n of k is going to decrease, right? So n of 1 is greater than n of 2, so that's fine, right? Because here I have 1 bigger than 2. N of 2 is less than n of 3, so n of k continues increasing. But then n of 3 is greater than n of 4, so the function n of k is no longer increasing. And what is the consequence of that? The consequence is that I'm moving along my original sequence forward, right? But then I move backward when I go to 1/8. And that's not allowed because then I'm choosing elements not in order. So, therefore, from here I see that n of 3 is greater than n of 4, so n of k is not just not increasing, not just not strictly increasing, it's simply not increasing. And so therefore this is not a subsequence.